In this lesson, you're going to learn about naming acids, you're going to learn about binary acids, and you're going to learn about oxyacids and how to name all of them in a quick and easy fashion. All right, you will need your periodic table, and you're also going to need your polyatomic ion sheet. And if you don't have a polyatomic ion sheet, go to the link below and get. It's totally free, and it'll be a helpful tool for you. Has a lot of good information on it. All right, you must know Lewis dot symbols, oxidation numbers, covalent and ionic bonds, the periodic table, and polyatomic ions. You need to be familiar with these. You need to know how to use the periodic table. Remember, that is your most important tool in the chemistry class. What exactly is an acid? Acids have at least 3 possible definitions. But for right now, all you need to know is that acids are compounds that release hydrogen cations, that's positive ions, when dissolved in water, when they are aqueous. And that gives us an acid. And here's an example. Hydrogen chloride, when dissolved in water, gives us hydrogen ions and chlorine ions. And there we have it. It's an acid. There are 2 types of common acids. There are binary acids and there are oxyacids. So there are 2 basics. And of course, binary acids are aqueous solutions of binary compounds that produce hydrogen ions. And here's some examples. And naming binary acids goes as such. First, you use the prefix hydro, the root of the other substance, add the suffix IC, and then say acid. Here's an example. HCl. There's my H, so I say hydro. There's my chlorine, and the root for chlorine is chlor, so hydrochlor. Add IC, hydrochloric, and say acid, hydrochloric acid. Now, if you need to review that, rewind and go through it again. And here's some practice. And up in the right-hand corner, you see I wrote the rules. And remember to refer to your common ions sheet, your polyatomic ion sheet. Refer to that. It's an awesome reference. All right, HF. Let's name that. Fluor hydrofluoric acid. Again, we know it's going to be hydro and iod for iodine. Hydroiodic acid. Pretty simple, isn't it? Now, this one is a polyatomic ion. There are cyanide. And so we look up its root, and it would be cyan. And so hydro cyanic acid. Pretty cool. H2S. And we see sulfur. And so that would be hydrosulfuric acid. H with the Br, that's brom, and add IC, and we have hydrobromic acid. It's really just that simple. Now, let's look at oxyacids. Aqueous solutions of compounds contain hydrogen, oxygen, and a third element. And here's an example, H2SO4, and the third element is sulfur. Okay, oxyacids are named from the polyatomic ion. So, in SO4, we'd use sulfate. In NO3, we'd use nitrate. And PO3 is phosphite. And how these end is very important. So we need to know the polyatomic ion. Therefore, the reason we need to have the polyatomic ion sheet out. Or memorize them. Either one. Naming oxyacids. If the polyatomic ion ends in ATE, use the root of the third element and add IC, an acid. Use the root of the third element, add IC, and acid. That's if it ends in ATE. Let's try some. An example, HNO3. Well, NO3 is our polyatomic ion, and it is nitrate, so it ends in ATE, so we're going to add IC, and that would give us nitric acid. If the polyatomic ends in ITE, use the root of the third element and add OUS and acid. Again, it depends on the ITE knowing those polyatomic ions. Let's do an example. HNO2, there's our polyatomic ion, and it is nitrite, and nitrite ends in ITE, so add OUS. So nitrous acid. All right, let's practice a few. Up in the right-hand corner, I've put a little box of the rules. And we need our polyatomic ion sheet. And let's get started. H2SO4. Well, SO4, that's sulfate. It ends in ATE, so I'm going to add IC. So it would be sulfuric acid. Now look at that for a moment and just realize we took the root sulfur, added IC, and said acid. Sulfuric acid. All right, H2SO3, sulfite. And that is going to give us sulfurous acid. ITE means add OUS. HiO4, the polyatomic ion, is periodic acid. ATE means add IC. H3PO4, phosphate. ATE again, so we're going to add IC, phosphoric acid. And then H3PO3. PO3 is phosphite. ITE means OUS, phosphorus acid. Pretty simple, isn't it? Just got to remember the rules. All right, let's recap. Two types of common acids, binary acids. You take hydro, add the root of the other substance, and add IC and say acid. Oxyacids use the polyatomic ion. Therefore, if it ends in ATE, you take the root of the third element, add IC and acid. If it ends in ITE, you take the root of the third element, add OUS and acid. There's our rules. That's how to do it.